Hello everyone, welcome back to my YouTube channel. I am Sindhu from Sri Venkateshwara College of Engineering, Bangalore. Now in this video, let us discuss about calculus in motion, that is exploring the power of vector calculus. Coming to the contents, what we will discuss in this video are what is vector calculus, vectors and vector operations, gradient, divergence and curl, Stokes theorem and Green's theorem, application of vector calculus and at last conclusion. Coming to what is vector calculus. Vector calculus is a branch of mathematics that deals with functions of several variables and their derivatives, primarily involving vectors in three-dimensional Euclidean space. It has become an essential tool for physicists and engineers to describe physical phenomena such as electromagnetism, fluid dynamics, and mechanics. At its core, vector calculus is concerned with the study of how quantities change over time and space. By using vectors, we can represent both the directions and magnitude of these changes, allowing us to better understand complex systems in the natural world. Whether you are interested in designing aeroplanes or studying the behavior of subatomic particles, vector calculus is an indispensable tool for making sense of the world around us. Coming to vectors and vector operations. A vector is a mathematical object that has both magnitude and direction. It can be represented graphically as an arrow in space. The length of the arrow represents the magnitude of the vector, while the direction of the arrow represents the direction of the vector. Vectors can be added, subtracted, and multiplied by scalars. When two vectors are added, the result is a new vector that points from the tail of the first vector to the head of the second vector. When two vectors are subtracted, the result is a new vector that points from the head of the second vector to the tail of the first vector. Scalar multiplication involves multiplying a vector by a scalar, which changes the magnitude of the vector without changing its direction. The dot product is a way of multiplying two vectors to obtain a scalar. The dot product of two vectors is equal to the product of their magnitudes multiplied by the cosine of the angle between them. The dot product is used to calculate the angle between two vectors to project one vector onto another. Another important operation is vectors is the cross product, which results in a new vector that is perpendicular to both of the original vectors. The magnitude of the cross product is equal to the area of the parallelogram formed by the two original vectors. Coming to gradient, divergence and curl. In vector calculus, gradient, divergence and curl are three important operators used to describe physical phenomena. The gradient measures the rate of change of scalar field with respect to distance. It is represented by the symbol delta and is often used to describe the direction and magnitude of a force acting on an object. Divergence, on the other hand, measures the flow of a vector field out of given point. It is represented by the symbol and is often used to describe the behavior of a fluid in motion. Finally, curl measures the rotation of a vector field around a given point. It is represented by the symbol delta cross and is often used to describe the behavior of a magnetic field. These three operators are essential tools for understanding many physical phenomena. From fluid dynamics to electromagnetism, they allow us to describe complex systems in terms of simpler mathematical concepts, making it easier to analyze and predict their behavior. By studying gradient, divergence and curl, we can gain a deeper understanding of the world around us and the forces that govern it. Coming to Stokes theorem and Green's theorem. Stokes theorem and Green's theorem are two of the most important theorems in vector calculus. With significant applications in physics and engineering, Stokes theorem relates a surface integral of a vector field to a line integral of its curl around the boundary of the surface. This theorem is used to calculate circulation and flux of fluid flow, as well as electromagnetic fields around closed loops. Green's theorem relates a double integral over a region to a line integral around the boundary of the region. It is used to calculate work done by a force field along a closed path, as well as to calculate areas and volumes of various shapes. Both theorems are essential tools in the study of fluid dynamics, electromagnetism, and other branches of physics and engineering. Coming to applications of vector calculus. One of the most fascinating applications of vector calculus is in the field of fluid dynamics. By using vector calculus, scientists and engineers are able to model the behavior of fluids in a variety of situations. From the flow of air over an aeroplane wing to the movement of blood through the human body. Another important application of vector calculus is in the field of computer graphics. By using vectors to represent objects in three-dimensional space, computer programmers are able to create realistic looking images and animations that can be used in movies, video games, and other forms of digital media. Coming to conclusion part, in conclusion we have learned that vector calculus is a powerful tool for describing physical phenomena in mathematics and physics. We explored the basic concepts of vectors and vector operations, as well as the three main operators in vector calculus: gradient, divergence, and curl. We also discussed the significance of Stokes' theorem and Green's theorem and provided examples of how vector calculus is used in various fields such as physics, engineering, and computer graphics. It is clear that vector calculus plays a crucial role in modern science and technology. From modeling fluid dynamics to designing complex computers simultaneously. As we continue to push the boundaries of what is possible, it is important to recognize the value of this fascinating subject and continue to explore its potential. Whether you are a student, researcher, or simply curious about the world around us, I encourage you to develop deeper into the world of vector calculus and discover its many applications. Thank you for watching this video.